Hi folks, welcome back to Physics with Captain Rod. The purpose of this video is to just talk very briefly about calculating the work done by a potentially variable force along some sort of path. All right, so we're going to imagine here we've got this object, and imagine it's moving along this curve here that I'm going to call curve S here. And it's acting under the influence of who knows how many forces, but I'm just going to talk about this one in general here. Again, there could be more. So this force very likely can vary with position. So as we move along this path, the magnitude of this force might be changing, as is the angle here. There's some sort of angle, which I'm going to call theta, between the force vector and the motion along this path. So, work is force times distance, but that's not going to be good enough for us here, because in theory here, this force could vary in both magnitude and direction as we move along this path here. So what I'm going to do is we're going to think about this in a little bit more mathematical sense. I'm going to define a small displacement along this path. All right, so that would be maybe a little ds vector. And again, what this is a small displacement. So that would take this from here to maybe here, and another displacement from here to here, and another one from here to here, and so forth. And what we can do is we can write in a short equation here that gives us the work done by this force over this small distance ds. Now remember, work is force times distance. However, only forces parallel to the motion do work. If you see my video about two-dimensional forces and displacements and calculating work, remember when you're calculating the work, you need the component of the force vector in the direction of motion times the distance. So the work done as we move from here to here is going to be magnitude of F times the cosine of the angle between the force vector and the displacement vector. That's going to give, and I'll draw this in red, that gives the component of this force in this direction. And then we'd multiply by the distance ds. Oops. Now, in the language of vectors, all right, this is magnitude of one first vector, magnitude of the second, cosine of the angle between them. In the language of vectors, that's a dot product. So what we're looking at here is f dot ds. F dot ds gives the differential amount of work done by the force F as we undergo a small and infinitely small displacement ds. So this really is a dw, that's a differential work. And then the total work done, as we go from position 1 to, I'll just call this position 2, you would add those all up. So you'd integrate F dot ds from position 1 to position 2. That gives you a value for the work done by this force as this particle moves along this path. So again, this was meant to be just kind of a conceptual video here. I'm not going to work any problems in this example. I'll go ahead and save that for another time. I just wanted to talk a little bit about how to get from what I would call algebraic version of work to the differential version here, which we'd use in in a little bit more complex problems. So hope this video helps demonstrate that. Have a great day.